Hello everyone. Today we're going to do packet switcher of CCNA1 version 79.3 for packet switcher IPv6 neighbor discovery. Here's a addressing table, device RTA. RTA is a router, and the three PCs, PCA1, PCA2, PCB1. From this topology, we can tell that these two computers, PCA1 and PCA2, are in the same subnet network 1. And PCB1 is in subnet network 2. This is an IPv6 address. We know that in IPv4 has 32 bits, and we use binary to create the IPv4 address for the network address and host address. In IPv6 has totally 128 bits, and we use hexadecimal value to create IPv6 address for the network address and host address. And these 128 bits are evenly split into two parts. The first part, 64 bits, represent the network. The other part, 64 bits, represent the host. And also, these 128 bits are evenly split into 8 hexadecimal. And these hexadecimal are divided by the colon sign. And each hexadecimal has 4 digits. These digits are hexadecimal digits. And each digit has 4 bits in binary. So each hexadecimal has totally 16 bits. And the first 3 hexadecimal represent the network. It is called 48 bits global routing prefix, which is assigned by the ISP, Internet Service Provider. And the fourth hexadecimal represents the subnet. It is called subnet ID. The other 64 bits or other 4 hexadecimal represent the host portion IPv6 address. Like here, the double column A represent the host portion IPv6 address of PCA1, and the double column B is host portion IPv6 address for PCA2, and the double column A is for PCA1. These letters are hexadecimal value represents the host portion IPv6 address. Oh, okay, objectives. Part 1, IPv6 neighbor discovery local network. Part 2, IPv6 neighbor discovery remote network. Background. In order for a device to communicate with another device, the MAC address of the destination must be known. With IPv6, a process called neighbor discovery using NDP or ND protocol is responsible for determining the destination MAC address. Here, the NDP is similar to the ARP in IPv4. ARP is ARP, Address Resolution Protocol. Both NDP and ARP have the same function, that is to find the destination MAC address. You will get the PDU information in simulation mode to better understand the process. There's no packet tracer scoring. Okay, instruction part 1, IPv6 neighbor discovery local network. Local network is the communication between two devices that are in the same subnet network 1. Yeah, that is a local network communication. These two computers are in the same subnet network 1. In part 1 of this activity, you will obtain the MAC address of the destination device on the same network. Step 1, check the router for any neighbors that it discovered. Neighbor is a neighbor table. Okay, let's go. Router, CLI, here's a command line interface. So right now we're in the user executive mode. We use command enable to enter the privileged executive mode, and from here we use show command to show IPv6 neighbors. So in my case, there's no any neighbor information displayed here. But in your case, if you see any neighbor information, you got to use second command, clear IPv6 neighbors, to delete the neighbor information or delete the neighbor table. The neighbor table is stored on the router, so we delete it. PCA1 command prompt. Okay, PCA1 command prompt. You go here. Okay, step 2, switch to simulation mode to capture events. So here we are on the real-time switch to simulation mode. So here's the simulation panel. Show none, show all to display none. So here there are 2 events here. We show none. Okay, no events displayed here. If you click again, all the events were displayed here. Okay, show none. That's what they ask us to do. And so now go to PCA1 here, ping PCA2. So from PCA1, ping PCA2. So let's go to ping space dash n is number, space 1 is 1 time, space followed by the PCA2's IPv6 address, which is 2001 colon db8 colon ACAD colon 1 double colon B. Okay, enter. Okay, so then play capture forward. These 2 buttons, both are capture forward button. You can click either one. So here capture to 0 second. So capture forward button. So here capture to 150 second. Look at here. Here's a sent one, received one. Because usually Windows will automatically ping 4 times. The sent 4, received 4. But here's only sent 1, received 1. That's because when we ping, we limit the ping time to only 1 time. So number 1 time. So only ping 1 time. That's why it's a sent 1, received 1. Then go to edit filter. Edit filter is here. IPv6 tab. We select ICMPv6 and NDP. ICMPv6 is for ping. NDP is neighbor discovery to find the destination MAC address. So, okay, let me adjust the size of the column so we can see it easily. Okay. All right, so now there are 2 PDUs present here. The question is, why are ND PDU? The yellow one is ICMP, the green one is NDP PDU. Why NDP PDU displayed here? That's because before we ping, remember that, before we ping, we delete the neighbor table on the router. And the destination MAC address is on that neighbor table, but we deleted. So without the destination MAC address, this ping cannot be completed. In other words, without the destination MAC address, this ICMPv6 packet doesn't know where to go physically. Even though we know the destination IP address, but IP address is a logical address. Any computer can be configured as the same IP address. Like here, if we change this computer to another computer and put it to here, the another computer can be configured as the same IP address. But a MAC address is different. MAC address is a physical address. It is burned into the hardware. So each computer has a unique MAC address. And also, the communication between these 2 computers is a NIC to NIC communication. So in order to complete complete this pin, the source device has to know the both destination IP and the destination MAC address. But now without the destination MAC address, so the source device has to use NDP to find the destination MAC. That is a function of NDP. Okay, here is the answer. I explained already, so you can read the answer. It's the same as what I say. Next, so click the square in the type column for the first event. Should be ICMPv6 here. ICMPv6 at PCA1. All right. Okay, so because the message start with this event, there's only outbound PDO, yeah. So under OSI model tab, the question, what is the message type listed for ICMPv6? Here's OSI model. The OSI stand for the Open System Interconnection. The question, what message type? Here, the ICMPv6 echo message type 128. So here, ICMPv6 echo is for ping. Here, the echo is echo request with the number 128. So here you see echo request, number 128. Later on, you will see the echo, but with number 129. 129 is echo reply. 128 is echo request. So remember that. So here's the answer. Okay, echo reply 128. There's no layer 2 addressing. No layer 2 is addressing. Yeah. So click next layer. Okay. To get explanation. Okay, so the next hop IP. So before doing that, look at here. Source IP, destination IP, both source IP and destination IP are the global unicast, global unicast IPv6 address. When we study IPv6 address, there are different type of IPv6 address. When you see the IPv6 address starting with 2001, this type of IPv6 address is global unicast address, also called GUA. GUA is a routable IPv6 address. Okay, so the next hop IP address is unicast. Yes, unicast address. ND process looked it up in the neighbor table, but we deleted the neighbor table. The next hop IP address is not in the neighbor table. That's correct, because we deleted it. NDP process sends neighbor solicitation. Solicitation is a request for IPv6, for IP address. So the next step right now is layer 2 MAC address information missing. So next step, we need to use NDP process to find the layer 2 addressing information, especially the destination MAC address information. So next, click square next to the event in the PCA1 NDP. Okay, PCA1 NDP is here, second one. And question, what changed in layer 3 address? Layer 3 is IP address changed. So the source IP is still global unicast address. It is the source device IP address. Source device IP address should be the double column A is PCA1's IP. And destination IP changed to this multicast IPv6 address. This is another type of IPv6 address. When you see the IPv6 address starting with FF02, It is multicast IPv6 address. Okay, so the answer is here. Okay, destination address, MAC address change, IP address changed to the multicast IP. And here the message is a neighbor message type 135. Here neighbor is a neighbor request. Neighbor request here. Neighbor process is a neighbor solicitation. Solicitation is a request with the number 135. Later on, you will see neighbor, but with the number 136. 136 is neighbor reply, but now is neighbor request with number 135. Okay, so here is, and the second question here, what layer 2 addressing are shown? Layer 2 MAC address. Here the source MAC is still source device MAC address. Destination MAC is multicast MAC address, starting with 3333 is the multicast MAC address. Okay, this is the answer. MAC address is PCA1's MAC. Destination is multicast MAC. So when a host does not know the MAC address of the destination, a special multicast MAC address is used by IPv6 neighbor discovery as the layer 2 destination address. This is the special multicast MAC 3333. Next is NDP at switch A, NDP switch A. The question, is there any difference in the in layers and out layers for layer 2? Here's in layers, layer 2, out layers, layer 2. In layers is for information coming in, out layer for information sending out. Their layer 2 information source MAC, destination MAC, source MAC, destination MAC. They are the same. So the answer is no, no difference. That's because a switch here doesn't do anything to the layer 2 information, doesn't change layer 2 information. Switch only forward the packets or only pass the packet. Okay, so here next, select the first NDP at PCA2. So PCA2 is a destination device, PCA2 NDP here. Click outbound PDU details. Okay, go here. So what address are displayed for the following? All right, so we copy this destination address. This destination address is MAC address because this address is under Ethernet 2. Ethernet 2 is layer 2. So we copy this destination MAC, source MAC, destination IP, or destination IP, source IP to here. Okay, so destination address is PCA1, source is PCA2, source IP PCA2, destination is PCA1. So here, the source address and destination address is switched because this is an outbound PDU. Let's go to OSI model so we can see in layers coming in information, out layers sending out. So here, coming in is a labor request. So this destination device PCA2 receive a neighbor request with the number 135. After process this packet, the PCA2 will reply, the neighbor reply back to the PCA1. So this neighbor reply will travel in opposite direction to the PCA1. So that's why the source address and destination address switched. So here, source IP is a source device IP, PCA1, become the destination IP. And the destination IP is multicast, change to the source unicast IP. This unicast IP is PCA2, destination device IP. And the source MAC changed to destination MAC. And before, the multicast destination MAC become the unicast source MAC. This unicast source MAC corresponds to this unicast source IP, which is PCA2. So this MAC address is PCA2's MAC address. So now the neighbor reply bring this destination device MAC address back to the source device. Then the source device PCA1 will use it to complete the ping. That is the process of NDP, neighbor discovery protocol. Next, select the first NDP event at RTA NDP. Okay, here. The question is, why are there no out layer? No out layer, okay, C. No out layer. That's because we're at router. Router receive information. This is the neighbor request from PCA1, 135. Because router receive this neighbor request packet through this default gateway interface. And in this neighbor request, the destination IP is multicast address. But this default gateway interface IP address should be the unicast address. Let's go to see RTA. Okay, RTA. The IPv6 address, first one in the middle, 20001. That is the default gateway IP address. It is a global unicast address. So this global unicast address and this multicast address doesn't match. So that's why this neighbor request packet was dropped by the router or by the NDP process. That's why no out layer information sending out from router. Okay, here's the answer. Okay, you can read the answer. Next layer to the end, 4 to 7 steps. Okay, 1. Four to 7. The packet is an NDP packet, yes. Device process it. So after router receive it, router will process it. And the ND packet is neighbor solicitation. Solicitation is a neighbor request. And the neighbor solicitation target IPv6 address. Target IPv6 is a destination IPv6. Destination is multicast address. Doesn't match the receiving ports address. Receiving ports is default gateway interface port. Interface IP is a unicast. We see that. So they don't match. So NDP process drop the packet. Okay. Next, IPv6, PCA1. PCA1, IPv6, next one. Okay. So question, does PCA1 now have all the necessary information to communicate with PCA2? Yes. The destination IP is here, global unicast. Destination MAC is unicast, which is PCA2's MAC. Okay. The answer is yes. Next, click IPV6 PCA1. The last IPV6, the last one is here. I think it's here. And PCA1. Yeah, this is the last communication. So what is the IPv6 echo message type? Here's the echo message type is 129. As I said, 129 is echo reply. So this is the answer. Okay, 129 echo reply. So here, click reset simulation. Reset simulation. Okay. And from PCA1, repeat ping PCA2. Okay, PCA1, repeat ping PCA2. I use up arrow. Again, so this time only one PDU displayed here, which is IPv6. The question, PV6. All right, so capture forward button 5 times. Okay, there's 1, 2. This is the echo request. 3, 4. From now on is echo reply. 5. Okay, so ping successful. Question, why weren't there any NDP events? Because in the previous steps, we use NDP to find the destination MAC address already. So right now, PCA1 uses it to complete the ping. So the NDP process is completed. We don't need NDP. That is the answer. Here's the answer. Okay, you get a read. Okay, we finished part 1. Part 2, IPv6 neighbor discovery remote network. Remote network. In part 2 of this activity, you will perform steps that are similar to those in part 1, except in this case, the destination host is on another LAN. Observe how the neighbor discovery process differs from the process you observed in part 1. Pay close attention to some of the additional addressing steps that take place when a device communicates with a device that is on a different network. Reset. Okay, reset. And connect to real time. Okay, before we continue, I want to talk about a little bit difference between the local network and the remote network. In the part 1, in the local network, from source to destination is only one hop from source to destination. But part 2 is a remote network. Remote network is the communication between two devices that are in two different networks. So like here, PCA1 is in subnet network 1, PCB1 is subnet network 2. So the communication between these two computers is remote network communication. So in the remote network communication, from source to destination, it's not one hop, it's two hops. Two hops. That's because the router involved. Router creates another hop. Because the function of the router is to interconnect the different networks. So router create a hop. So the first hop from source to destination, the first hop is from source to the router. The second hop is from the router to the destination, the two hops. So when the packet travel remotely to different network, the IP address doesn't change because IP address can travel anywhere, doesn't change. But a MAC address doesn't. MAC address only can travel within the same network. MAC address only can travel the same network. So when the packet wants to travel to a different network, the packet has to go through the default gateway, the router. So for the first hop, the source MAC, still the source device MAC, the destination MAC will become the default gateway MAC. So in the second hop, another default gateway MAC address will become the source MAC, and destination MAC is a destination device MAC. That's the difference. All right, so here, step 1, capture events for remote communication, display and clear entries in the IPv6 neighbor table. Okay, here, router. So let me show IPv6 address neighbor. Oh no, show IPv6 neighbor. So no neighbor. Okay, clear neighbor. So now there's no neighbor table on the router. So switch to the simulation mode. All right. So here, display none. Okay, same. And PCA1. At this time, PCA1 pin PCB1. PCB1 is in another network. Okay, PCB1 is in different network. Okay, let's ping. I still use up arrow and the change to PCB1 is in subnet network 2. And the host portion IPv6 address is A. All right. Ping. And capture forward button. So here's a 0, capture forward button, become the 150. Is that correct? Yes. Edit filter, go to IPv6 and ICMPv6 NDP. Okay, close. So 2 events displayed here. So right now there are 2 PDU displayed here. Square. The first event is ICMPv6 on PCA1. Okay, it's the same because the message starts with the first event, so no, only outbound PDU. Okay. So and the layer 2 information missing. That means when you see layer 2 information missing, that means the next step you need to use NDP to find this layer 2 information, especially for the destination MAC address information. Okay. Yeah, the source IP, both source IP, destination IP are global unicast IP. So next, click NDP, PCA1 NDP. So now the NDP process starts to find the destination MAC address. The question, what address is being used for source IP in the inbound PDU should be outbound PDU. Okay, so here is source IP. Look at here, source IP. Before, the source IP is global unicast address, but now the change to is another type of IPv6. It is a link local IPv6 address. When you see the IPv6 address starting with FE80, this type of IPv6 address is called link local address. Okay, here's the answer. So FE80, the link local address. Link local address is not routable. The link local address only can be used within the same subnet network. The link refers to subnet. Yeah, and we'll determine the next destination. Okay, so click the second IPv6 on PCA1. Second ICMPv6 is this one. And PCA1 now has enough information to create ICMPv6 echo request. Yes, because PCA1 has both destination IP unicast and unicast destination MAC. So the answer is yes. Question. No, is enough information. Yes, but the question is what MAC address is being used for the destination MAC? Here, as I said, for the first hop, the destination MAC should be the default gateway MAC address. So here, 6301. So here, the MAC address, the first one all the way to the right, 6301. That's default gateway MAC address. It is the destination MAC for the first hop. So here's the answer. Next, click IPV6 at router. Okay. Next, DP. Oh no. No, next SMP router. Notice that outbound PDU. IPV6 router. IPV6 router. Okay, it's here. Discovery. Okay, so here on the router, the layer 2 information missing. That means the router will use the next step. Router will use NDP to find the destination MAC address. Here, that is for the second hop. The router will use NDP to find the destination MAC address, PCB1's MAC address. Okay, because here's the echo request, 128. Skip to the first IPV6 event for the PCB1, ICMPV6 first. This one. Okay. So what's missing? Outbound layer 2 information. Yeah. The layer 2 information missing. The source MAC and destination MAC missing. Okay, here's the answer. Layer 2 source destination MAC address are missing. So that means the PCB1 will use NDP to find the destination MAC address. So here the echo is echo reply 129. Echo reply is reply back to the source, back to the router. So the destination MAC should be default gateway MAC. Events addressing an event. Skip to the last set. IPV6. Notice this have been learned. The required information is now. No, the PCB1 can send a echo reply. Okay, back to yes. Click the reset simulation button. PCB1 repeat ping. Okay, so reset and the ping again. Let's ping again. Ping PCB1. I use up arrow. Ping PCB1. Okay, ping again. So this time, only one PDU displayed here. Okay, click 9 times. So here, click 9 times. So 1, 2, 3, 4, 5. Yeah, here's the echo request. 7, 8, 9. Okay, now the ping is successful. The question, so click the 9 times. Were there any NDP? No. That's because in the previous steps, we use NDP to find destination MAC address already. So the NDP process is completed. We don't need NDP anymore. Okay. Process complete. Click the only PCB1 IP event here. PCB1 event here is this one. Question: what does the destination MAC address corresponds to? Corresponds to destination. Here, destination MAC address is here. As I said, the MAC address only can travel within the same network. So the destination MAC should be the default gateway MAC. So here's the destination 6302. Let's go here. The middle second one. No, all the way to the right. Second one, 6302. That is the default gateway MAC address of the subnet network 2. Okay, so yeah, here's a echo reply 129, echo request 128. The answer here is yeah, corresponds to the default gateway. You can read it. The question here, last one. Why is PCB1 using the router interface MAC address to make it ICMP PDU? That's because this is the echo reply back to the source. The PCB1 is in another network. So the default gateway MAC address should be the destination MAC. Here is the answer. You can read. All right. Return to real time. So click the router. Okay, click the router. And show IPv6 neighbor. Okay, I use up arrow, show IPv6 neighbor. So here, question, how many addresses are listed? There are 4. 1, 2, 3, 4. 4 addresses. And the second question is, what devices are these addresses associated with? The PCA1 and PCB1. All right. So there are 2 computers, but 4 addresses. So that means each computer has 2 addresses. Look at here. The double column A, that is PCA1's global unicast address. The third one is the PCA1's link local address. Link local address is not routable, but global unicast address is routable. But these 2, the first one and third one, have the same MAC address, E8ED, E8ED. The link layer address is MAC address, because that means the same computer has 2 IPv6 address. So, and because here's E8ED, E8ED. Okay, they are the same E8ED, they're same on the same MAC address. Are there any entries for PCA2 listed? No. That's because this remote network communication only happened on PCA1 and PCB1. The PCA2 doesn't involve. That's the reason. Here's the answer. So ping PCA2 from router. PCA2 from router ping. Okay, let's ping. PCA2 is 2001 column DB8 ACAD column 1 double column B. All right, success. So then to show neighbor again, show IPv6 neighbor. Okay, now the question, are there entry for PCA2? Yes, this one, double column B is PCA2's IPv6 address. This is the PCA2's MAC address. The answer is yes. Okay, here there's a interesting, see here, look at here. This is PCA1's MAC address E8ED, but the default, the link local address is E8ED. Look at here. 7E, here's the 7E. And the 42, here's 42. And the 01 and 01. Okay, so from here we can tell this link local host portion IPv6 address is created by using EUI64 process. What is EUI64 process? EUI stands for Extended Unique Identifier. This process is to turn this MAC address into the link local address host portion. Because we know the MAC address also use the hexadecimal value, but here is only 48 bits because it's 3 hexadecimal. This process has 2 steps. The first step is to insert FFFE in the middle of MAC address. Middle is between 2 and 7. That's the middle of the MAC address. So insert FFFE in the middle of MAC address between. So here, insert FFE in the middle of MAC address. Here, this MAC address is between F and 6 and F and 6. The second step is turn the 7th bit to 1. If the 7th bit is 0, flip 0 to 1. If the 7th bit is 1, flip it to 0. Here in our case is the 7th bit is 0, so we need to flip to 1. As I said, the MAC address using the hexadecimal value. So each digit, this hexadecimal 4 digits. Each digit has 4 bits in binary. So the 7th bits should be on the second digit, 0. So this 0 in binary should be 0, 0, 0, 0, 4 zeros. So we flip the 7th bit, is flip the third 0 in binary, okay, to 1. So the second digit, 0, 0, 0, 0, will become 0, 0, 1, 0. So 0, 0, 1, 0 in binary and convert back to the hexadecimal value. This 0 will become 2. Okay, so this hexadecimal will become 0201. And in short, it is 201. Here is 0260. In short, is 206. So this is the EUI64 process. 2 steps. First, insert FFFE in the middle of MAC address. The second step is flip the 7th bit from 0 to 1. If the 7th bit is 0, flip it to 1. But if the 7th bit is 1, flip it to 0. This case, our case is the 7th bit is 0, so flip to 1. All right, it's very interesting. And so the reflection question, it's very simple. I just give you the answer. When does a device require the IPv6 neighbor discovery process? When the source device doesn't know the destination MAC address, the source device will require the NDP process to find the destination MAC. The next question is, how does a router help to minimize the amount of IPv6 neighbor discovery traffic? The answer is the router just keeps the neighbor table. It doesn't need to initiate a neighbor discovery for every destination host. The next, how does IPv6 minimize the impact of the ND process on the network? The answer is IPv6. In IPv6, there's no broadcast address. IPv6 use a special multicast destination address to listen to the neighbor discovery message. So only a handful of addresses would be listening to the neighbor discovery message, which includes a portion of the node address. So the last question, how does neighbor discovery process differ when the destination host is on the same LAN and when it is on the remote LAN? Here's the answer. Yeah, when the destination host is on the same LAN network, only the host that matches the IPv6 address responds to the message. The other devices drop the packet. When the destination host is on the remote network, the MAC address of the local LAN default gateway interface on the router will become the destination MAC address. Then the router keeps searching for the MAC address of the destination device on the remote network. The router will then place the corresponding IPv6 and MAC address pair in the IPv6 neighbor table. It is similar to ARP table in IPv4. I'm going to talk a little bit difference between IPv4 ARP table and IPv6 NDP neighbor table. It is about their location. In IPv4, the ARP table is stored in both switch and router, and we need to use different commands to access the ARP table. On the switch, we use command show MAC address table to access ARP table. On the router, we use show ARP to access ARP table. And in IPv6, the NDP neighbor table is only stored on the router. We use command show IPv6 neighbors to access neighbor table. The switch doesn't do anything to the layer 2 information. Switch only pass the packet. That's the difference between IPv4 ARP table and IPv6 neighbor table, NDP neighbor table. Yeah, their location is a little bit different. Okay, we finished this packet tracer. Okay, IPv6 neighbor discovery. Thank you for watching my video. If you like my video, please thumbs up and subscribe my channel, share with your friends, leave comments, and see you next time.